Alright, welcome back to the channel today. We're solving July 6th question, pass the pillow. So let's read the questions. There are n people standing in a line labeled from 1 to n. The first person in the line is holding a pillow, and then every second it will pass to the next one. So we're given n indicating how many people standing in the line, and time to be how many times we want to pass a pillow. When it reaches the n people, it starts passing backward to the person before that. So direction changes. So let's say we have n equals 4 and times equal to 5. So people pass the pillow in the following way. So they pass from 1 to 2 to 3 to 4. When they reach 4, they only passes 3 times, so they move to change the direction and pass to the people before them. Right, so one of the way of brute forcing is that we can just have a count and then decrement time every time we pass it until time equals 0, and then we return whoever is holding the pillow. Right. So for this, we can initialize the count equals to 1, initiating that the person is count right now, and then we can have a direction. I will set front equals to true. So while time is greater than 0, we should still have some remaining time to pass to people. And then I said if count equals 1, and then I want front to be true. If count equals to n, means you reach the last person, you want going front to be false. So there's like direction check. Right. So if front, we want to increment count by 1. Else we want to decrement count by 1 because we're moving forward. Right. And then at the end, we want to reduce the time because we pass to next person every time, and then we return count. It indicate which person is holding it at the end. Let's run this code. Submit it. 39 milliseconds, speed 29.62%. Right. That's another way that I would do is using a math. Right. So let's say we have n equals 5 and time is equals to 4. Right. So we'll see that if we have time equals 4, it's 1, 2, 3, 4. So even though we have n equals 5 people, we actually only need n minus 1 time to pass to the end. Right. So let's see if we have n equals 5, time is equal to 7. So now we have more time than the actual line of people have. So we'll see that we pass 1, 2, 3, 4, and then coming back 5, 6, 7 times, back to 2. In this case, I'll bring to two cases where one is we end when we are passing forward, and the other one is when we're passing backward. So when we're passing backward, right, we can say we can find the number of turns by using the time divide by n minus 1 to see how many turns we are making. So in this case, we're making 1 turn, so we are moving from the back. Right. The other example is, let's say we have n equals 5, time equals 10, right? So we find the number of turns again by the time divided by n minus 1, which in this case we'll find that this is 10 divided by 4, and then it's 2. Means that after dividing, we can find that the number of turns we're doing is 2, which is an even number, so we're moving forward. So in this case, we can find something called remanding. Means you can forget whatever in the first row, but we're just looking at the last time that you're coming back, right? So the last time is the only action we care about, so we can use time mod n minus 1, because n minus 1 will be how many, n minus 1 will be the number of time you get from 1 to the n, right? And then we don't care about that. We only care about the last remaining mod that you're moving. So we can say remaining to be time mod n minus 1, and in this case is 3. We can do the same when it's an even. So we can also find the remaining by finding the time mod n minus 1. So at the end, when the number of turns is odd, we count from the back. So we found that the rebending for this is 3. So we can say n minus 3, which is 5 minus 3, and then because we're moving 3 times in the last sequence. So we can say this is 2. And for the even one, we can, instead of using n minus, we can use 1 plus because we're starting at position 1. So in this case, time mod n minus 1 is 2, because you can see this 2 remaining here, and I could use 1 plus. Right, let's dive into the code. So in the beginning, we see that we need to find number of turns, and then we need to find the remaining, and then we return based on number of turns. So we can say number of turns equals time what divide by n minus 1, and then we can set if number of turns mod 2 is equal to 0, and this is even, and then we return 1 plus the time mod n minus 1. Else we return n minus time mod n minus 1. Let's run this. Then let's submit this. So this one 35 milliseconds, bit 49.11%. And then let's analyze the time complexity. This will be O of 1. Oh, the runtime just get worse because I used the other account, and then apparently it just ran 25 milliseconds and bits 96.96% of people. But anyways, you can see this is all one solutions, and I hope this video is helpful. Always comment if you have any questions, and see you tomorrow.